Hello, people. I'm mixing it up and standing over here right now. I won't be able to do it for very long, I'm sure, but I'm ready to be done making videos. So I'm just teaching you in person instead, but I can't because you're not here. So here we are with the videos. So section 12.4 on page 820. Inscribed angles, and guess what? A circle. Okay, let's review. Here we have a circle with a central angle. Remember, if it has a central angle, the central angle is equal to the arc degree. Same thing. Okay? This right here is an example, two examples actually, of inscribed angles. Central angle, because it's coming from the center. Inscribed angles, I can't do anything with inscribed, but these are inscribed angles. They come from one side of the circle and they end at the other side of the circle. They're half. This angle is half this arc. So if this arc is 140, this angle is 70 degrees. Just half. If this is 80 degrees, this arc is 80 degrees. Same, central angle. Inscribed angle, it's half. Okay? Hey, this is exciting and you're just going to have your minds blown. But if I drew another inscribed angle in this circle and it had the same endpoints as this one, what do you think is true about these angles? They're the same. Because they intercept the same exact arc, they're both half, therefore they're the same thing. Inscribed angles, ladies and gentlemen, very exciting. Okay. Example number 1 on page 821. See, now I'm going to have to switch over here because I could only do it for so long. All right. RST, angle RST. Notice in our example, angle RST is up here. And it runs into an arc that's 120 degrees. Remember, the angle is half the arc. So if the arc is 120, the angle is 60. Okay, B, SU. Okay, well, SU goes to here. This is S, this is U, this is R, and we know that R is 40 degrees. It's an inscribed angle, so the arc that it hits is twice that, and it would be 80. Okay, the crazy thing, I think you're thinking, well, this is great, no problem. You're right, it is, it's no problem. But as you know, they'll draw super crazy pictures that are really kind of hard because there's so many lines going everywhere and you won't know exactly what they're wanting. So that's the part that gets tricky in this, okay? Let's turn to page 822. If I have a circle and I inscribe an angle in that circle and the endpoints of that angle happen to be the endpoints of a diameter, this is 180 degrees, right? So this has to be a right triangle. So if your inscribed angle intercepts the circle at a semicircle, like the ends of a semicircle, then your angle is 90 degrees. It's a right triangle. And all the right triangle things now apply. Pythagorean theorem, etc. Okay? Let's look at example 3a. What is the value of x? Well, in our picture, mine is drawn sideways, but we'll just use the same one. They tell us it's 4x plus 6 right here. Well, since this is the diameter, you know it's 180 degrees right here, right? So therefore, that is half, which means it's 90. So I can just make that equal to 90 and solve for x. All right, with b, I told you this a second ago. It looks like angle ADC has the same endpoints as angle ABC. So therefore, angle B and angle D are the same. So you would do 10y minus 28 equals 7y minus 1. Because it was one of these. They both have the same endpoints, so therefore this angle is the same as this one. We can make the equations equal each other, and yay, solve for y. Okay. Page 823. If you have a quadrilateral, that's 4 sides. inscribed inside a circle. It touches every corner or vertex touches the circle. Then opposite angles of that quadrilateral are 180 degrees total when you add them up. So on example number 4, Q and S would equal 180 and P and R would equal 180 because it's a quadrilateral inside a circle. So opposite angles are supplementary, which means 180. Of course, you already knew that. So I would make 6y plus 1 and plus 10y plus 19 together equal 180 and solve for y. Okay. I know, I explained it really short. I tried to be really fast. Hopefully it will be enough for what you need. Question. I love my new bracelet, but why does it have the word angle written on it? I don't even get this joke, you guys. Question. I love my new bracelet, but why does it have the word angle written on it? Oh, now I get it. I'm very slow today. It's your very own inscribed angle. Your very own inscribed angle. You're welcome.